Hello everyone, in this tutorial we're gonna start to see how to create a raycast car in Godot. Today we're gonna create the suspension, and I plan to address other parts like accelerating and steering in the following videos. You can take a look at my latest video to see what kind of behavior we're trying to achieve. Without further ado, let's get started. Let's create our car scene and save it, and change the type from Node 3D to rigid body. And let's add a collision to it. But first, let's also add a mesh and adjusting accordingly to resemble a car. Now change the collision shape to match the mesh. You can hold Alt to help scale on both sides at the same time. Next, let's create our wheels that are actually 4 raycasts. We may also create a Node 3D wheels to group them so we can manipulate them together. After that, let's add our car to the main scene. Also add the camera 3D and adjust its position. Add a collision to the ground and let's run our game. As you can see, our car falls directly to the ground, and this is expected since we don't have any script yet. So let's create one and call it car. Now we're going to create 4 exported variables, starting with the suspension rest dist. You can think of it as the spring length. The next one, spring strength. It is the stiffness of our spring. Then we have the spring damper. That is the force that will try to stabilize our suspension. And the last one is the wheel radius. Those are values you can change later. Let's create now the wheels script. You may delete this generated code, we don't need it. Let's start creating a variable to reference our car, since we're gonna apply the force to it, and also we need access of those variables we created before. Add the physics process function, and then let's start our code. The first thing is to check if the raycast is colliding with something. We need to define the direction our suspension is going to move. So in our case is the y-axis. Next, we need to calculate the distance between the raycast origin to the point where it is colliding with the ground. Now we can calculate the spring length. That is basically the suspension rest distance, but we want a clamped value because we want the minimum to be 0. We don't want a negative value here. The spring force is the compression of the spring, which we can calculate by subtracting the spring length from the suspension rest distance times the spring strength. To calculate the spring velocity, we need to do the previous spring length minus the current spring length. We don't have this previous spring length yet, so let's create a variable to store it. Now we're able to calculate the spring velocity. Also, divide the result by delta. Now we can calculate the suspension force. That is basically the basis dot y, that is the axis we want to apply the force, times the spring force that we calculated before. And also, let's not forget to update our variable previous spring length with the spring length. Before applying the force to the car, we need to calculate the point where this force will be applied. It is the collision point, but we want to consider also the car wheel, so we apply the force a little bit higher, simulating the center of the wheel. Finally, we can apply the force to our car using the apply force function. It takes two arguments, the force and the position we want to apply. For the force, just use the direction we defined earlier times the spring force, and for the position, we use the point variable minus the car global position, so we can get the point in relation to the car. Let's test to see if it works. Actually, we got an error because our getParent is returning the wheels node, and we need to return the car rigid body. So we need to use getParent.getParent. Let's try again. Another error. This time the suspension is written wrong. Okay, one more time. And I forgot to specify the y-axis. So let's fix it and try again. Okay, now our car seems to be applying some force, but it's not working as we expected. So let's first install this add-on to help us to visualize better the scene. It's called Free Lock Camera. So let's install it. And just attach the script to our camera. Let's run again. It seems to be applying some force, but it's not enough to lift up the car. As you can see, our raycasts are colliding. Actually, we forgot to attach the scripts to the other wheels. So let's fix it. And try it again. Okay, our car is bouncing. Our suspension is working. But there's a problem. We don't have anything to stabilize our suspension. Our car keeps bouncing infinitely. This happens because we are not using the damper force that is responsible for stopping the spring. But before that, let's just configure our project to run the window always on top, the application, so we can debug better since we can move our car in the editor and it will reflect on the game running. So the damper force is just the car spring damper value that we informed, and times the spring velocity. And we use this force in the suspension force equation below. Let's run the game now. It seems there is an error on the code. Here it should be plus sign, not times. Let's fix it and try again. Okay, it seems now our car is stabilized. As you can see, it's not bouncing, but the damper force is too high. Let's try to decrease a little to 2. Okay, it bounces a little and stabilizes. Let's try 1. Okay, now it takes longer to stabilize the car. Let's try to decrease the spring strength. Okay, now it's more real, right? It's more smooth. Okay, so you can play with these values to see one that you like, but that's it. It's basically this. Our suspension is working. Now let's activate the Jolt Physics so we can test it with it. Go here at the Physics 3D and choose the Jolt Physics 3D and restart godot. And okay, now we have Jolt active. Let's test the game. Our car seems to be flying. What's happening is that our wheels are colliding with our car and not the ground, so it keeps applying the force constantly. So let's create here the ready function and call the function add exception and pass our car, so it will not collide with Raycast. Let's now try again, and as you can see, it's working like before. You can also activate the bug so you can see the collisions. Let's run again. And now we can see the raycasts colliding. That's it. I hope it was helpful to you, and bye.